We are now going to set up a system of linear equations to solve this problem. So let's spend again a minute or so to read the problems. The nutrient information in one serving of food A and food B is given in the following table. And so here's the table. Food A for protein, these are the units measured in grams per serving. So food A for protein, it has 3 grams per serving in food A, where carbohydrates in food A has 11 grams per serving. And similarly, food B has protein, has 5 grams of proteins per serving and 9 grams of carbohydrates per serving. So the problem wants us to use this information to find how many servings of food A and food B are needed to get exactly 20 grams of protein and 64 grams of carbohydrates in a meal. So let's now identify the variables, including finding out how many variables being involved here. And so this problem mainly concerns about food A and food B and how much protein in each of these and how much carbohydrates in each of these. And we're going to look directly into the ultimate question here, asking how many servings of food A and food B that's needed to get exactly 20 grams of protein and 64 grams of carbohydrates. So this is quite a lengthy question, but right here from this beginning part of the question, how many servings of food A and food B are needed? So in that case, immediately we are instructed that we're going to be looking at 2 separate variables. So now I'm going to define a letter A to name my variable. So let A represent the number of servings of food A, and I'm going to let capital B to represent the number of servings of food B. And once again, those are the only 2 variables we have found and identified in our problems. So here we are having 2 variables. So 2 variables means ideally we should be looking for 2 relationships among the variable. And so continuing to read further into the question, it's further indicated that the problem needs to have exactly 20 grams of protein and also needs to have 64 grams of carbohydrates in total, after totaling up the 2 different foods here. So having exactly 20 grams of protein means from food A, which contains 3 grams per serving, but A servings of food A total up together with food B, some B servings of food B at 5 grams of protein per serving, total up all these 2 amounts of protein is required to be at 20 grams total. So now we have found one relationship between the 2 variables. 3a plus 5b equals 20. The problem also requires the two foods coming together to have 64 grams of carbohydrates in a meal. And so, once again, with a number of servings for food A, but being at 11 grams per serving for carbohydrates, and with B servings of food B at 9 grams per serving of carbohydrates, totaling up these two quantity of carbohydrates is required to be at a total of 64 grams. So here we have found another relationship between the two variables, and so ideally we were looking for two relationships, and now we have found both of them. So here we have for ourselves a system of equations, two unknowns, two variables, and two equations. And so once again, solving this system of equation, we can take different ways to solve the method. One way we can solve by using the substitution method. On one hand, we can also, somebody else can solve this by the elimination method. And the third method is the matrix method, where we solve the system by using an augmented matrix and for those who are solving this system of equations, of linear equations, by using an augmented matrix, then this system produced the following augmented matrix. Notice how the variables are being lined up in columns. So according to the column for A, we have 3 times A and 11 times A in the bottom row. So here we have a column reading 3 and 11. Looking at the next variable, which is lined up in one column among the two rows here, then we have a column of 5 and 9. And the equal signs line up as one vertical line. And the numbers on the other side of our two equations take another column, being 20 and 64. And what we now have ended up here is an augmented matrix. We can use any online tool or a software program or your standard TI-8384 calculator. We have this RREF command to row reduce this matrix, this augmented matrix, or we can row reduce this augmented matrix by hand. So since the methods running the reduction of this matrix by using the RREF command from a standard TI-83 and 84 is being introduced in class, so I am going to be using the TI-83 and 84 RREF command to reduce this augmented matrix. So running the RREF command from our TI-83 and 84 calculator, we ended up with this system. After row reduced, 1, 0, 5, 0, 1, 1. And so now the way how this final matrix reads, this first column, once again, remind yourself that it's equivalent to our first variable. So the A variable is here. So this reads 1A plus this column here is equivalent to your b variable. So top row as an equation reads 1a plus 0b equals 5. So that means we found some value for a suggested to be a equals 5, and now I'm using the word suggested here means eventually we're going to need to check our solution before we can make the final conclusion. Second equation reads 0a plus b equals 1, which is the same as b equals 1. So now we have found a pair of values, a equals 5, b equals 1. Let's check our solution. So we found that a equals 5 and b equals 1. So now I'm going to go ahead and substitute a equals 5 and b equals 1 into our first equation to produce 3 times 5 plus 5 times 1. And let's find out if it's equals to 20 on the right hand side. And yes, calculation does show that 3 times 5 plus 5 times 1 equals 20. So meaning our two values we found for a and b here do satisfy the first equation. And now let's move on and check our second equation at these two found values. So 11 times 5 plus 9 times 1. We want to know if the left hand side will come out equals 64 on the right hand side, and that's what my question marks are for. And yes, calculation does show that this is 55 plus 9, that does equal 64. And so now, in other words, our final solution now can be concluded to be a equals 5 and b equals 1.